As a network administrator, you'll be asked to troubleshoot a number of different network issues, so you need to be sure you have the right network tools in your tool bag. If you're building your own cables, then you'll need a cable crimper. This is the device that pinches the modular connector onto the end of the cable. This cable crimper, for instance, has two different connectors on the end, one that is a 6 position, which is for RJ11, and one is an 8 position, which is used for crimping RJ45. This is usually the last step of the process. You've run a cable from someone's desk, you've run it up the ceiling, it's gone all the way down into a network closet, and now you need to put a connector on the end of that cable. You'll put the modular Ethernet connector on and use the crimper to fasten it to that connection. The crimper's job is to take the copper that's inside of that modular connector and push it through the insulation of that wire so that you have copper-to-copper connectivity going from the wire itself into the connector and ultimately into your network device. Let's look at a modular connector that has not been crimped onto a wire. Before you use the crimper, you'll notice the copper connections are sticking out just a little bit. When you finally perform the crimp, it will push down all of those copper connections. And you'll notice they have these pointy tines at the end of the connectors. Those are the connections that are going through the insulation of the wire and making contact with the copper that's inside of those wires. Once you make the crimp, you'll notice that the copper connectors are now down inside of the connector itself. And notice that those pointy connections at the end have now been pushed into the wire itself to make that copper connection. You'll also notice that the crimper pushes in a piece of plastic at the bottom that holds the cable in place. That way, once you've made this good crimp, there's no way for that wire to accidentally pull out of the connector. If you're going to be troubleshooting or working with these copper connections, you're going to want a good pair of crimpers. You might also want a good pair of cable snips. These are also called electrician's scissors. And optionally, you might also want a good wire stripper, especially if you're working with different kinds of wiring and need a quick way to strip away coax or other types of wired connections. You also want to be sure that the modular connectors that you're using match the type of cable you're connecting to. Category 6A cabling will require connectors that are designed for Category 6A. So make sure that the crimper and the connectors you're using all match the wiring that you're running on your network. Performing the actual crimping process is a bit outside the scope of the Network Plus exam, but if you do start building out your own cables, it may seem a bit difficult at first to work with these very small wires, get them in the right order and into the modular connector. But after some practice and a number of times of crimping down the wires in the wrong order, you start to get the hang of it, and it becomes a lot more easy to troubleshoot and to replace these copper connectors on these modular Ethernet runs. Another incredibly useful tool to have in your toolbox is a multimeter. This can provide voltage and continuity settings. For example, you can plug into a power source that's providing AC power and measure exactly how many volts of AC power is coming from that connection. It's a good way to check to see if a particular power source is either working or not working, or maybe providing a different amount of voltage than what you were expecting. The multi in multimeter means that it does more than one thing. You've got a number of different voltages and settings that you can check for. And of course, you can check for DC voltage as well. So if you'd like to check the voltage coming from a laptop power supply or PC power supply, or you'd like to see how many volts are available in a battery, the multimeter is a great tool to use. These multimeters are also great for performing continuity tests. So you can check a fuse to see if the fuse is still working. Or you can check pins on both sides of a wire to see what pins on one side are connecting to which pins on the other side. This allows you to build a wire map to determine the type of wiring you might be working with. If you have more than a couple of wires in your environment, then you'll want to invest in a tone generator. This allows you to follow or track where a wire is going from one end to the other by simply following a tone. This is usually two different components. One is the tone generator itself. You plug this into the wire and it places an analog sound onto that wire. The other piece of this tone generator is the probe. This is an inductive probe, which means it doesn't have to physically touch the copper to be able to listen in to that audio that's being placed by the tone generator. You just need to get close. And then there's a small speaker that is on the inductive probe that allows you to listen in to see if you can hear that tone coming through a cable. This means you could have a bundle of hundreds of cables and still be able to trace exactly what cable you're looking for in that bundle. You simply connect the tone generator to the wire. This tone generator can connect to many different types of connections. It could be coax or RJ11 or RJ45, and then you use your inductive probe to find the sound that's coming through the wire. Here's 4 Ethernet cables that are on my network, and I put a tone generator on the other end of one of these cables, but I don't know which one of these it happens to be. This, of course, could be a bundle of 100 cables, but the process is exactly the same. I take my inductive probe, which has a button on the front that I hold, and I simply touch the inductive probe to the different cables. You'll notice you don't hear anything, you don't see anything, but when you finally get to the cable that does have the tone generator on the other end, you'll hear the sound, you'll see the light flashing, and you know that this must be the cable that has that tone generator on the other side. Now that we know where the 2 ends of this wire happen to be, we may want to connect a cable tester to those 2 ends of the wire and perform some simple continuity tests. A cable tester is going to be able to tell us if all of the pins are connecting from pin 1 to pin 1 on the other side, pin 2 to pin 2, and so on. If there are any missing pins or crossed wires, it may identify those as well. The cable tester tells us if we've wired things properly, but it doesn't tell us the quality of the wiring. If we need to perform crosstalk analysis or frequency tests, then we may want to use a time domain reflectometer, which is, of course, a much more advanced function than something like a cable tester. Your toolbox may also include a number of loopback plugs. These are used to send traffic going out of a particular interface, loop them around, and send them back into that same interface. It's also good for fooling different applications that are expecting to have an Ethernet connection available, even if you aren't directly connected to a live Ethernet network. The type of loopback plug that you'll use will depend on the type of interface that you're connecting to. For example, you can have serial or RS-232 loopback plugs, some that are 9-pin and some that are 25-pin. There's separate loopback plugs that you would use for Ethernet, T1, or even fiber connections. But the important thing to remember is that these are looping back traffic from one interface back into the same interface. These are not crossover cables, which allow us to connect different devices to each other. In many environments, there may be a wall of punch-down blocks. This is the intermediate section between a user's workstation and the networking equipment that might be in a closet. We would take all of the cables from the users and punch them down into these punch-down blocks. But to be able to do that, we need the right punch-down tool. This might be punching down into a 66 block or a 110 block, and there are different connectors for the punch-down tool depending on the type of punch-down block that you're using. This can be a bit tedious because we're taking every single one of those connections, we're splitting out those 8 wires, we're putting them into the 8 different slots in that punch down block, and then we're using the punch down tool to individually punch down those wires. It does help, though, that as you are pushing that wire into the punch down block, the punch down tool is also trimming the wire and making a neat connection in the block itself. So you can see here the punch down tool has pushed all of these wires into the block. You can see the connectors inside of the block have pierced the plastic insulation on the outside and making the copper connection metal to metal between the punch down block and the wire itself. And you can see at the end of these that all of these ends have been nicely trimmed as it was punched down into the block. If you've ever seen these large walls of punch down blocks, you know that there's a lot to keep organized, and that's why it's important to always document exactly what wires are plugging into what connections. Your punch-down blocks may even have numbers associated with these, and you're able to document exactly what wires are plugging into what connections. Another important consideration is that you maintain the twists. The person that performed these punch downs did a very good job of keeping the twists as close as possible to the punch down block itself. You don't want to have a large amount of wire that has been removed from the sheath and then spread out and then finally put into the punch down block, especially when you're running higher speeds of Ethernet. You want to make sure to maintain those twists as close as possible to the block. With all of these connections, you'll often find some documentation on paper that is written and posted right next to the punch-down blocks, or sometimes there may be tags or information you could put on the wires themselves. Sometimes the wall itself will have writing from the person that performed the punch-down, so you may need to look closely behind the wires to see exactly what was written during the punch-down process. We've talked a lot about copper tools that we need in our toolbox, but we also need tools that allow us to see the wireless networks as well. A Wi-Fi analyzer is going to be able to see all of the different communication over your Wi-Fi network and give you feedback on signal strengths and exactly what frequencies may be in use on your network. This might be a purpose-built appliance or device that you carry around with you that is specifically designed to provide Wi-Fi analysis, or it may be additional software that you load onto an existing mobile device that gives you this capability. Either way, you'll be able to see all of the frequencies that are in use in your area. You'll see if there's any errors or interference and be able to manage exactly how you can configure your wireless network to perform optimally.